Hello guys, in this video I would like to explain that how we can implement Kolmogorov-Smirnov test, which is usually used for the comparison of two datasets, whether the two datasets belong to the same probability distribution or not. First, I would like to explain briefly what is Kolmogorov-Smirnov test, and then I would like to explain this with the data. Two datasets because one dataset is very closed. I mean that in one panel the datasets are very closed, so you will see different p-values, and in the other the datasets are little far away from each other in terms of mean and variance, so you will see different p-values. To explain what is mean by how for which type of data we can accept and for which type of data we can reject this test, and what is mean by the rejection and acceptance of the null hypothesis. Okay, so let's move toward what is mean by Kolmogorov-Smirnov test. If you Google Kolmogorov-Smirnov test, one data sets detail, just Google it, Kolmogorov-Smirnov test for one data set. You will see like this. And statistic, the Kolmogorov-Smirnov test, case test, is a non-parametric test of the equality of continuous or discrete. Okay. Nationality probability distribution that can be used to test whether the sample came from a given reference probability distribution or not. So this is one sample case. Does this mean that you can use this distribution to test whether the sample data came from a specific probability distribution or not? So you can test the distribution of the data. Remember, this is a one sample test. And on the other hand, if you search Google two data set like this one, you will see this is different. This means that whether the two data set have the same distribution or not. So this is the different than the other. For the first one, for the one sample, you can use case test to test the distribution of the data, whether the data is belong to a specific probability distribution or not. In this case, you test whether the two data sets belong to the same probability distribution or not. So this is important. We have done already two videos by comparing data set using the probability density function, using mean and medians, and then quantiles. So the link is mentioned in the description of this video to those two videos. So the purpose is you can compare data graphically and numerically as well. Numerically mean by calculating the p-values of the Kolmogorov-Smirnov test, and to see because graphically you may see that the two data sets are very close, but you can confirm this by numerical evaluation by using this case test, whether the data sets belong to the same probability distribution or not. And this is quite important when you are doing some evaluation of the different model performance. You can compare that whether the data set of the particular model is close to the reference observed data or not. So you can see detail on Google it and you will see detail. Let's move to the R and RStudio, that how you can do this. Okay, this is the R code. I have simulated multiple data sets like X1 or norm function. This will generate random number from normal distribution 500 observation, mean 30 and standard deviation 5. Similarly, X2 with these parameters, mean is just changed to 29 and there is no much change. In this case, X3 mean is changed to 31 and in X4 mean is changed to 30, but the standard deviation is now 4.5 instead of 5, which is remain the same in the previous three data sets. I will generate these data sets and the data will be stored in X1 for this, X2 and so on, X4 for these parameters. Then I just use this command to make specific place for these graphs. The margins, specify the margin, and this is to divide the windows into two windows, two columns and one row. And this is for row, so you can change the rows as well. If you want to make it 2 by 2, then you will get four parts in this window for the graphs. Then I plot the density as I mentioned already in detail. Density, you can see the previous videos. Plot the density of the first data set and then line, second, third, and fourth. Okay, so this is just the plot. Then I just wanted to mention the mean as well. Why not? We can draw the mean value for each data set to see the mean value difference in the data. And then I applied the KS test. Remember, KS.test is used to implement the KS test. You can write here in like comment test. Okay, and this should be with the comment hash. Similarly here. So this means that KS test mean in this case that we are comparing second data, this data, as remember that I just assume this X1 as a reference data. This means that I'm comparing this data set with this data set. In your case, if you are comparing your data, maybe you are doing climate change analysis or hydrological analysis or some other financial analysis. So in that case, suppose you are talking about climate change, so you will have an observed data and you will have 3 models. Suppose in this case, maybe you have 4, 5, you may have 20 models. So you are comparing these model data with the reference baseline observed data to see which model closely approximated this reference data, observed data. So in this case, I assume this is the reference data. Just for explanation, you can do according to your data. So I'm comparing X2, this data with this X1, and then the third data with X1, and then the fourth data. I mean, of course, you can say this is the third data if you are considering this the reference data. So first data, second data, and third data. I'm comparing these data set by using, because I already told you that in the KS test for 2 data sets, you need 2 data sets. So one is the reference data, the observed data, and I'm comparing all these data sets. So I will get a p-value for each of them, and then I will decide whether the data belong to both data set belong to the same distribution or not. Remember the null hypothesis that both data belong to the same probability distribution. I can show you. You can see the null hypothesis is that the 2 data set values are from the same continuous probability distribution. Okay, so let's do like this. And then, okay, I will do like this for one data set because there is little variation. I mentioned already, little changes in the parameter. And then I will draw the data because I want to plot the data, the density function, the mean values, and then the p-values for each data set to see in a full description, graphically as well as numerical. And now this is the second data set. Okay, you can see the full legend. So this is about the legend. Okay, here. Now the second data set, there is a little more variation in the second data set, like norm, same name is mentioned, but you can name it differently. X1, 500 observation, 30 is the mean, and 5 standard deviation. X2, 500 observation, 35 is the mean. Remember this little more difference in the mean value, and standard deviation is also changed 6. From 5 to 6. X3, 500 observation, 40 is the mean value, and 7 is the standard deviation. And similarly, this the mean is 45, and with the standard deviation 8. Again, in the same way, I plot the data, and then I mention the mean value for each data set to see how much the mean is changing. And then the case test, as I explained earlier, for comparing each of the 3 data sets with the first this assumed baseline observed data to see which data is. This is just for the comparison, for the explanation. Of course, this data is deviate more than this. I already know this. So this is just for, a tutorial for explanation. You can use your model data. In the next video, I will explain with the model data, so you will understand this better if you are confused in this one. And then I will graphically I will draw. And remember that, okay, I will explain this later, not now. So let's draw this, run this. Okay. Let's see what is the error. This is warning, so just forget about this for the moment. Okay, the first data, second data, third and fourth. So these are the different data sets. Now I just want you to draw the mean line. So this is for the reference observed data, second data, third data, and fourth data. You can see the difference. the mean values, because sometime you can see the mean. You can compare data set by quantile, as I mentioned in my previous video, so you can see. Now I want to test this case test, and remember the null hypothesis is that data sets belong to the same probability distributions. So you can see that the p-value here is 0.16. So this means that if the p-value, if you are testing at 0.5 at 5% level of significance, this p-value should be, if this is less than 0.05, this means that you reject the null hypothesis and conclude that the two data sets do not belong to the same distribution. In this case, the p-value is 0.01, so this means that this is, we reject the null hypothesis. In this case, the p-value for the second one, the p-value is 0.05, and this is, you can say, greater than 0.05, so you can accept that the two data sets belong to the same probability distribution. And the third case, as I already mentioned, the mean values are very close to each other. So this means that the two data sets are very close to each other in variability as well. So this means we have higher p-value, 0.2262. This means that we accept the null hypothesis and conclude that the two data sets belong to the same probability distribution. This is okay. You have done these plots with the mean values. And now I want to mention the legends in self-explanatory graphs. So I mean, I want to mention the p-values on this graph as well. So for this, I'm doing like this. I just mentioned that, okay, this is just a general. You will see when I plot it, then observed, model, and then I mentioned the p-value. Remember, this is the p-value. You can see the p-value for the first data set. If it is wrong, you can change it. Okay, the p-value is 0.01, so you can change it to 0.0. And remember x1 and x2, we are testing this one. Okay, 0.2 because round up. For the second data set, the p-value is 0.06. You can say, if you might round up, 0.06. And for third data set is 0.022. Yes. 0.2. Okay. So, and then you need to mention the color. Black color is for this one, and black color is for observed. I don't, because I want to differentiate between other data set, model data set, and observed data set. So I just mentioned this. And then model 1 with the p-value, model 2 with the p-value, model 3 with the p-value. And you can, the color text you can also change like this. Now just draw this, plot this. Remember that you also need to mention the data, the variable name. So I have another legend like this. So this is, you know, you can write the data name. I mention X, you can change it. It's up to you. Remember, data underscore p-value. So this is observed. I don't have p-value because I am comparing model data with this data. So no, model 1 with the p-value 0.02, model 2 with the p-value 0.06, and model 3 with the p-value 0.2. So this is now self-explanatory graph. You can mention something here if you want on the x-axis when you are plotting this plot. As I mentioned in my earlier videos, you can mention whatever is on the x-axis, number of days, temperature, precipitation, or whatever. Now let's move to the second plot. This is the second data set. Simulate the data. Okay. Okay, now plot it. You can see there is a shift in the data in the variability as well as in the mean value. Now mean value, you will see the mean value is moving to the right because I have changed this simulation. Case test. The p-value is very high because this is quite obvious. The data is different. 2.2 e power minus 16, very low value. Mean we reject the null hypothesis and conclude that the two data sets do not belong to the same probability distribution. Similarly for this one, because it's moving away the data sets. And similarly, this one, now you need to mention the name. As I mentioned, why you can write whatever is the variable name. And then the legend, of course. Okay, so let's plot this now again, and then I will interpret. Okay. Okay, now we have this, the final plot. These are data sets which are not very far away from each other. There's a little variability, but not too much. Like this data set, according to the test, this data set is different from the observed data. And you can see this is the observed data. You can see the mean difference. The mean difference is higher in this data. Remember, the red data set is little deviated from the black data, observed data. So the p-value is this one. For the green one, 0.06. Mean value is closer than the red, but not too much. And blue line is very close, just almost on the black data. So the p-value is higher. So we can accept that these two data sets are from the same distribution as the reference observed data, but for this data set, we can reject that the two data sets belong to the same distribution. Of course, they do not belong to the same distribution. In this case, the case is quite clear. And you can see black and the black mean, this is the observed data, and then this is shifted to right because we all simulated this according to, like this. Then the green and then the blue one. And you can see for all the data sets, the p-values are very, very much lower. So we can conclude that the data set does not belong to the same distribution as the black line, the observed data belong to. You can mention on the x-axis according to your variable, because I do not mention the variable name. It's just x and y. The next video I would like to explain the variable names as well as on the axis, because I will have proper variable, from the climate science or something like this. And this is just one explanation that how we can implement KS test for testing the distribution, the probability distribution of two data sets. And this can help you to validate your data sets, not necessarily for the model data, so maybe different experiments, output, and etc. For your paper report, technical report, research paper, and thesis, etc. In today's video, we have learned that what is mean by case test, what is case test for single data, and what is case test for two data sets, and how we can interpret the results. And then at the end, how we can implement this in our RStudio. I hope this video will help you. And if you found it interesting, please subscribe the channel. And I need your feedbacks as well. If you have any question, comments, you can write me in the comments. I will try to address that as soon as possible. Thank you so much, and see you in the next video. Ciao.